The Hurricane World War II proved to be one of history's most decisive aircraft, accounting for 60% of all Luftwaffe losses during the Battle of Britain, while its counterpart, the Spitfire, often captured the public imagination. The Hurricane dominated the skies with 32 RAF fighter squadrons compared to only 19 during this crucial battle. The Hawker Hurricane was a remarkable feat of engineering. It was significantly cheaper to produce than the Spitfire, requiring just 10,300 person-hours per airframe compared to 15,200 for its famous counterpart. This Hurricane fighter's innovative construction, using a tubular metal alloy frame with fabric covering, made it easier to repair and maintain in the field. By the time production ended in July 1944, 14,487 Hurricanes had been manufactured in Britain and Canada, serving in various roles from bomber-interceptors to ground support aircraft. Let's explore the special techniques of this aircraft. Revolutionary design features of the Hurricane fighter. In 1933, Sidney Cam boldly deviated from conventional biplane design, recognizing that single-wing aircraft offered superior speed potential. Initially, Cam proposed a design based on the successful Hawker Fury biplane, subsequently incorporating the Rolls-Royce Goshawk engine. His persistence led to multiple design iterations, notably introducing a retractable undercarriage and integrating the more powerful Rolls-Royce Merlin engine. The Hurricane fighter was remarkable, showcasing a masterful combination of established construction techniques and innovative features that set it apart from its contemporaries. Sir Sidney Cam, the chief designer, consciously decided to utilize traditional Hawker construction methods instead of adopting the stress scheme metal designs that were gaining popularity at the time. The Hurricane's primary framework was built around a worn truss box girder configuration. This configuration used high-tensile steel, longerons for strength, and duralumin cross-bracing for added stability. The components were mechanically fastened instead of welded, ensuring durability and ease of assembly or repair. In addition to its robust and efficient structural design, the Hurricane incorporated several advanced elements that enhanced its functionality and combat effectiveness. Among these features was a hydraulically actuated retractable landing gear, a significant innovation that improved aerodynamics and performance. The sliding cockpit canopy offered the pilot enhanced visibility, a crucial advantage in dogfights and other aerial maneuvers. Its armament was formidable for the era, with 8 wing-mounted Browning machine guns delivering a devastating firepower advantage. Furthermore, the inward retracting undercarriage was ingeniously housed within recesses in the wings, contributing to a cleaner aerodynamic profile and improved flight performance. The aerodynamic development process demonstrated remarkable thoroughness. In August 1934, engineers conducted extensive wind tunnel tests at the National Physical Laboratory using a 1/10 scale model. These tests confirmed the design's aerodynamic efficiency, leading to further refinements. The Royal Aircraft Establishment identified and resolved an early aerodynamic issue by adding a small ventral fairing and rudder extension. The Hurricane's design evolved through practical testing. The original tubulated propeller required modification after fighter command expressed concerns about low-speed performance. Subsequently, trials with a de Havilland variable pitch propeller reduced the takeoff run from 1,230 to 750 feet. The aircraft's sturdy construction proved particularly advantageous in combat situations, as cannon shells could pass through the wood and fabric covering without exploding. The design's versatility allowed for field assembly with basic equipment, demonstrating Cam's practical engineering approach. The high-mounted cockpit position prioritized pilot visibility, essential for combat effectiveness. This combination of traditional construction methods and modern features created an aircraft that balanced manufacturing practicality with combat capability. Engineering challenges in Hurricane development. The development of the Hurricane fighter presented unique engineering hurdles that demanded innovative solutions for all. The aircraft's construction required precise material specifications and complex assembly techniques that pushed the boundaries of 1930 manufacturing capabilities. Chief designer Sidney Cahn's strict adherence to mechanical construction over welded joints created specific material challenges. The aircraft's structure demanded high-tensile spring steel with engineering tolerances of less than 0.0005 thousandths of an inch on every bolt hole. Moreover, the center section required roll-formed, 10-sided front and rear spars with interference feed overlapping components. The choice of materials for the Hurricane was carefully tailored to balance the demands of structural strength with the practicalities of manufacturing. High-tensile spring steel was utilized for the primary structures to ensure durability and resilience under stress. The exterior covering was made from Irish linen, a material chosen for its lightweight properties and ease of application. Aluminum alloy was employed to craft the 16 handmade cowlings, offering a combination of strength and reduced weight. For the more intricate joint assemblies, heat-treated steel was selected, providing the necessary toughness and precision required for these critical components. The Hurricane plane were to feature hundreds of precision joints, with each connection point comprising between 20 to 150 components. Consequently, engineers developed specialized jigs and tooling for tube squaring equipment to maintain structural integrity. The center section integration proved especially complex, incorporating 3 fuel tanks with primary structure tubes passing directly through them. Several performance challenges emerged throughout development. The Rolls-Royce Merlin engine integration caused delays as engineers worked through multiple unreliable prototype variants before achieving success with the Merlin II, generating 1,030 horsepower. Additionally, the original two-bladed propeller demonstrated inefficiency at low airspeeds, necessitating a switch to the de Havilland variable pitch propeller that reduced takeoff distance from 1,230 to 750 feet. The aircraft's relatively unsophisticated construction resulted in additional weight, though this drawback provided unexpected benefits in combat situations. Specifically, the steel tube structure allowed cannon shells to pass through the wood and fabric covering without exploding, making repair straightforward for ground crews. Supply chain complications also affected production schedules. For instance, Canadian car and foundry faced severe difficulties with raw materials and components following France's capitulation in 1940. The shortage of Rolls-Royce Merlin engines and 3-bladed variable pitch propellers particularly impacted production flow, leading to aircraft being shipped without power plants. The Hurricane's unique construction method. The structural design of the Hurricane fighter exemplified a masterful blend of traditional craftsmanship and engineering precision. Chief designer Sir Sidney Cahn's distinctive approach shaped an aircraft that would alter the course of aerial warfare. The Hurricane aircraft's foundation rested upon a Warren Truss box girder framework, constructed with high-tensile steel, longerons, and duralumin cross-bracing. Each joint in this intricate network demanded extraordinary precision, incorporating between 20 to 150 components with engineering tolerances of less than 0.0005 thousandths of an inch. Primarily, Cahn insisted on mechanical fastening instead of welding, establishing a robust structure that could withstand substantial combat damage. The exterior construction of the Hurricane embodied a groundbreaking integration of materials that blended strength, flexibility, and efficiency. At its core, the primary framework was constructed from high-tensile steel tubes, providing a robust and durable foundation. Wooden formers and strainers were skillfully added to shape the fuselage, which was then covered with Irish linen, treated with nitrocellulose dope to ensure a taut, smooth surface. Aluminum alloy panels were meticulously crafted to form 16 handmade cowlings, contributing to the aircraft's refined aerodynamics and lightweight design. A pivotal advancement occurred in April 1939 with the transition to all-metal, stressed skin wings made from duralumin. This innovation marked a significant leap forward, as the metal wings enhanced the aircraft's capabilities, enabling an increase in diving speed by an impressive 80 miles per hour compared to the earlier fabric-covered designs. Beyond the speed improvement, these metal-skinned wings demonstrated superior strength, allowing them to endure greater stress loads while relying on less structural reinforcement. This evolution not only elevated the Hurricane's performance but also underscored its adaptability in meeting the escalating demands of modern aerial combat. The Hurricane plane World War II manufacturing process incorporated several groundbreaking approaches. A simple steel tube structure supported the engine, with detachable cowling panels enabling straightforward maintenance access. The center section's construction proved particularly innovative, featuring roll-formed, 10-sided front and rear spars with interference feed overlapping components. The manufacturing flexibility proved invaluable during wartime operations. Field crews could perform repairs using basic hand tools, altogether different from the complex maintenance requirements of monocoque designs. Similarly, the aircraft could be shipped in crated form and assembled near combat zones, maximizing deployment efficiency. The design's adaptability extended to specialized variants. The Royal Navy's Sea Hurricanes, stored efficiently aboard carriers in knockdown form, could be rapidly assembled when needed. From 1936 until production ceased in September 1944, various manufacturers including Hawker, Gloucester, Canadian Car and Foundry, and Ferry produced 14,233 Hurricanes, demonstrating the design's suitability for mass production. Advanced Systems Integration. The integration of advanced systems in the Hurricane fighter marked a significant leap in combat aircraft engineering. The aircraft's sophisticated components worked in harmony to create a formidable fighting machine. The Hurricane aircraft's armament underwent substantial evolution throughout its service life. The initial configuration featured 8 303 Browning machine guns mounted in the wings. Even more impressive, later variants carried an enhanced weapons package that included 12 303 Browning machine guns, 4 20mm Hispano cannons, 8 60-pounder RPM-3 rockets, 2 40mm Vickers S guns. Primarily, the Mark II Hurricane represented a major advancement in firepower, incorporating 4 20mm Oerlikon cannons that proved highly effective in combat operations. The Hurricane plane in World War II incorporated several pioneering control systems. A unique H-shaped lever, mounted on the lower right cockpit wall, managed both the flaps and undercarriage. In effect, this innovative design simplified the pilot workload during critical flight phases. The control column featured a spade grip pattern with an integrated gun-firing push-button and brake lever. The aircraft's hydraulic system utilized two separate mechanisms for undercarriage operation, one power-operated and another hand-operated. Hence, if both systems failed, pilots could manually release the retaining catches, allowing gravity to deploy the wheels. The Merlin 20 engine, introduced in 1940, brought remarkable improvements to the Hurricane fighter's performance. This power plant featured an advanced two-speed supercharger that pilots could adjust based on altitude requirements. The engine generated 1,280 horsepower, yet required a modified cooling system, using a 70% to 30% water glycol mix, as well as specialized tungsten alloy pipes throughout. The engine installation demonstrated exceptional engineering forethought. A simple steel tube structure supported the power plant, with detachable cowling panels enabling straightforward maintenance access. The liquid-cooled radiator, positioned beneath the fuselage, incorporated a hinge flap, allowing pilots to regulate cooling levels precisely. Canadian production variants faced unique challenges regarding power plant integration. The shortage of Rolls-Royce engines led to aircraft being shipped without power plants. This situation prompted the development of alternative solutions, including contracts with Packard Motor Car Company for licensed production of the Merlin engine, designated as V1651 in United States military service. Manufacturing innovations. Production efficiency marked a defining characteristic of the Hurricane fighter manufacturing process. First of all, the aircraft's relatively straightforward design enabled rapid assembly, requiring only 10,300 person-hours per airframe. The Hurricane aircraft manufacturing process primarily relied on established methods that facilitated swift production scaling. Upon receiving the initial order for 600 aircraft in June 1936, manufacturers developed specialized tooling and assembly techniques. Women comprised more than half of the Hurricane production workforce, demonstrating the adaptability of the manufacturing process. The production of the Hurricane extended across a vast network of facilities, reflecting its critical role in military aviation. Between December 1937 and July 1944, Hawker produced an impressive total of 9,986 units. The Gloucester Aircraft Company contributed significantly by constructing 2,750 additional aircraft. The Austin Aero Company completed another 300 units. Meanwhile, the Canadian Car and Foundry played a vital role overseas, manufacturing 1,451 Hurricanes. Throughout production, manufacturers maintained exacting standards through specialized quality control processes. The fabrication required numerous jigs, patterns, and specialized tooling. As such, more than 120 pairs of rows underwent careful design and manufacturing, using England's last remaining roll-forming machine. The quality control process incorporated specialized steel heat treatment procedures, primarily. This ensured consistent material properties across critical components. The mechanically jointed tube frame construction demanded precise quality oversight, with each joint requiring meticulous inspection before assembly. The Hurricane plane, World War II production, faced significant resource management challenges. Upon the outbreak of war, supply chain disruptions necessitated innovative solutions. The Canadian Car and Foundry facility demonstrated remarkable adaptability, developing alternative sourcing strategies when British component supplies became constrained. Critical component shortages prompted creative solutions. In September 1940, Britain contracted Packard Motor Company for licensed Merlin engine production. This arrangement proved vital, as Canadian production facilities had previously relied on salvaging engines from obsolete ferry battle bombers. The manufacturing process underwent continuous refinement to optimize resource utilization. Canadian Car and Foundry's chief engineer, L.C. McGoll, implemented efficiency improvements that enabled the completion of initial contracts 5 months ahead of schedule. The facility's success in resource management led to additional orders, despite initial skepticism from British Air Ministry representatives. Engineering solutions for combat requirements. Combat experience shaped crucial engineering modifications in the Hurricane fighter, transforming it from a basic interceptor into a battle-hardened warrior. These adaptations primarily focused on protecting vital components and enhancing survivability. The Hurricane aircraft underwent substantial armor upgrades throughout its service life. Early production models entered service without armor protection. However, combat experience in France prompted rapid modifications. The basic pilot protection package became standard in most fighters, incorporating armor plating behind the pilot seat. The comprehensive armor system ultimately included an armor-class windscreen for frontal protection, cockpit armor shielding, radiator armor reinforcement, and engine compartment protection. Indeed, these modifications emerged from battlefield innovations. British pilots, evidently learning from combat encounters, adapted armor plates from downed German aircraft to protect their cockpits. This field modification proved so successful that it became a standard factory installation. The Hurricane plane, World War II, featured a sophisticated fuel system designed to balance combat effectiveness with pilot safety. Engineers positioned fuel tanks strategically throughout the airframe, with the center section incorporating 3 separate fuel compartments. Undoubtedly, this distribution enhanced the aircraft's survivability by preventing total fuel loss from single hits. The fuel system's engineering demonstrated remarkable attention to detail. The center section integration proved particularly innovative, with primary structured tubes passing directly through the fuel tanks. This design simultaneously strengthened the airframe and protected the fuel supply. The Hurricane fighter's durability in combat situations exceeded expectations. Generally, the aircraft demonstrated exceptional survivability, with pilots reporting successful landings despite extensive battle damage. Ben Bowery of 111 Squadron documented cases where Hurricanes returned safely even with severely damaged wings. The aircraft's resilience stemmed from its unique construction method. The fabric-covered fuselage allowed enemy bullets to pass through without causing catastrophic structural failure. This characteristic, coupled with the robust tubular frame, enabled the Hurricane to absorb significant combat damage while maintaining flight capability. The effectiveness of these engineering solutions became apparent in operational statistics. Approximately 60% of Hurricanes shot down or crashed on British soil returned to service with Fighter Command. This remarkable recovery rate validated the design's emphasis on repairability and durability. The aircraft's toughness proved particularly valuable in ground attack roles, where exposure to anti-aircraft fire demanded exceptional structural integrity. Field maintenance capabilities further enhanced the Hurricane's combat effectiveness. The straightforward construction method allowed squadrons to perform major repairs without external support. Therefore, damaged aircraft could return to combat operations more quickly than contemporary fighters, requiring specialized repair facilities. Technical evolution through variants, continuous refinement, marked the evolution of the Hurricane fighter throughout its operational life. The Mark I, first delivered in December 1937, underwent numerous modifications that enhanced its combat capabilities. The Hurricane aircraft's power plant underwent substantial evolution. First, the original Merlin II engine generated 1,030 horsepower. Progressively, the Merlin III brought enhanced performance through ejector exhaust stacks for additional thrust. The introduction of 100-octane fuel in March 1940 enabled a boost increase from 6 pounds to 12 pounds, resulting in 1,305 horsepower in 5-minute bursts. A major advancement arrived with the Merlin 20 engine in 1940, featuring a 2-speed supercharger that pilots could adjust based on altitude. This powerplant delivered 1,280 horsepower, markedly improving performance at varying altitudes. The cooling system evolved alongside these changes, shifting from pure glycol to a 70/30 water glycol mixture. The Hurricane fighter aircraft of World War II underwent profound structural and functional transformations during its service life, reflecting the evolving demands of combat and advancements in aeronautical engineering. One of the most notable changes was the transition from fabric-covered wings to metal skin variants. This modification significantly enhanced the aircraft's capabilities, most notably by increasing its diving speed by an impressive 80 miles per hour. The improved wings not only contributed to better aerodynamic performance, but also allowed the Hurricane to pursue enemy aircraft more effectively, a critical advantage in high-stakes dogfights. Beyond the redesign of its wings, the Hurricane saw numerous other structural enhancements that bolstered its durability and survivability in combat. The radiator housing was reinforced with 350 pounds of armor plating, offering vital protection against enemy fire and environmental hazards. The cockpit received advanced protective systems to safeguard the pilot, ensuring that the aircraft could remain operational even in dangerous conditions. Fuel tank compartments were also strengthened, reducing the risk of catastrophic damage in the event of an attack. For operations in desert environments, additional modifications were introduced to adapt the Hurricane to the harsh conditions. Specialized dust filters were installed, protecting the engine from sand and debris that could otherwise cause severe damage. The Hurricane fighter underwent significant system enhancements throughout its development, increasing its combat versatility and firepower. The Mark II variant introduced a major upgrade with the addition of 20mm Hispano cannons, providing a substantial boost to its offensive capabilities. This improvement made the aircraft far more effective in air-to-air engagements and ground attack missions. The evolution continued with the introduction of the Mark IV, which featured a redesigned wing optimized for greater flexibility in armament configurations. This new wing design allowed the Hurricane to carry a variety of weapons and equipment tailored to specific mission requirements. It could be equipped with 250 or 500-pound bombs for precision strikes, 240mm Vickers guns for engaging armored targets, or 8 or P-3 rockets for powerful ground attack operations. Additionally, the aircraft could be fitted with 2 drop tanks, either 45 or 90 gallons in capacity, extending its operational range for longer missions. The aircraft's defensive capabilities consistently improved. Starting in May 1940, engineers added 70 pounds of head and back armor protection. Identification friend or foe equipment integration began in September 1940, adding approximately 40 pounds to the aircraft's weight. The canopy design underwent refinement to address visibility concerns. In October 1940, aircraft P-3889 received one of the first blown canopies, improving pilot visibility, particularly during combat situations. This modification addressed a critical combat requirement, as German pilots often exploited the Hurricane's limited rearward visibility. Canadian-built variants incorporated unique modifications. These aircraft often featured Packard-built Merlin engines instead of Rolls-Royce units, demonstrating the design's adaptability to different manufacturing sources. Engineering impact on combat performance. Engineering excellence manifested in remarkable combat capabilities for the Hurricane fighter, establishing its dominance across multiple theaters of World War II. First and foremost, the aircraft's design characteristics yielded exceptional performance metrics that proved crucial in aerial warfare. The Hurricane aircraft demonstrated superior turning capabilities against its primary adversary, the Messerschmitt Bf 109. The aircraft's wind loading of only 23 pounds per square foot enabled exceptional maneuverability. This characteristic proved particularly valuable in combat scenarios, as the Hurricane could outturn the Bf 109 at all operational altitudes. The Merlin engine's performance characteristics shaped the Hurricane's combat tactics. At lower altitudes, the Merlin powerplant delivered superior performance compared to the Daimler-Benz DB600 and one used in the Bf 109. Nonetheless, the DB60-1A-1 began outperforming the Merlin 3 and 12 above 15,000 feet. Combat tactics were shaped by the distinct performance characteristics of the Hurricane. The aircraft excelled in engaging bombers, benefiting from its exceptional gun stability, which made it highly effective in such missions. In contrast, the faster and more agile Spitfires were assigned the role of intercepting enemy fighters, leveraging their superior speed and maneuverability. When faced with aerial threats, the Hurricane relied heavily on turning combat as its primary defensive strategy, using its impressive turning radius to outmaneuver opponents and gain an advantage in close quarters engagements. The Hurricane plane, World War II, underwent substantial armament evolution to maintain combat effectiveness. Initially equipped with 8 300 and 3-inch Browning machine guns, this armament outgunned early Bf 109 variants carrying only for light machine guns. Ultimately, the Mark II introduced for 20mm cannons, substantially increasing firepower. The aircraft's stable gun platform characteristics enhanced combat effectiveness owing to its large, thick wings. The Hurricane provided exceptional firing stability. This attribute proved particularly valuable when engaging bomber formations, as pilots could maintain accurate fire for extended periods. The Hurricane fighter's protective systems evolved significantly based on combat experience. Initially entering service without armor protection, the aircraft rapidly incorporated essential safety features. The basic protection package included an armored seat and backrest, bullet-resistant windscreen, and additional cockpit armor plating. A notable engineering challenge involved fuel tank vulnerability. The gravity-feed fuel tank, positioned forward of the cockpit, presented a significant hazard, as defensive machine gun fire could cause catastrophic fires. As a result, engineers retrofitted the fuselage tanks with fire-resistant line-attacks material. The aircraft's structural design provided unexpected protection benefits. The fabric-covered rear fuselage allowed some cannon shells to pass through without exploding. This characteristic enabled pilots to return to base with substantial damage, where ground crews could quickly repair the aircraft using simple Irish linen patches. Landing gear engineering contributed significantly to pilot safety. The wide-track undercarriage design, featuring inward retracting wheels, provided exceptional stability during landings. In contrast to the Spitfire's narrow landing gear configuration, this design proved particularly valuable for inexperienced pilots and operations from rough airfields. The Hurricane's durability in combat situations proved remarkable. The sturdy tubular construction allowed many aircraft to survive significant battle damage and return to base. This characteristic proved particularly valuable during the Battle of Britain, where rapid aircraft turnaround was crucial for maintaining air superiority. Combat experience validated these engineering decisions. The Hurricane destroyed more enemy aircraft during the Battle of Britain than all other air and ground defenses combined. Furthermore, approximately 60% of Hurricanes shot down over British territory returned to service with fighter command, demonstrating the effectiveness of their protective features and structural durability. The Hawker Hurricane is a shining example of how innovative engineering can meet the intense demands of wartime. Its blend of traditional craftsmanship and modern design allowed it to excel in combat, while remaining practical to produce and maintain. From its tubular frame and fabric exterior, enabling quick repairs, to its devastating effectiveness in the Battle of Britain, the Hurricane proved both deadly and reliable. Its adaptability through technical upgrades, such as enhanced engines and advanced armaments, further solidified its legacy, with 14,487 units produced and a lasting impact on future aircraft design. The Hurricane remains a symbol of engineering brilliance. What are your thoughts on the Hurricane's role during World War II? Do you think its practical design or combat effectiveness was more critical to its success? Let us know in the comments. Thank you for watching.